Hi guys, you are welcome to my YouTube channel. In today's episode, we want to have a look at a very important aspect in physics, and this has to do with the fundamentals and derived quantities, as well as the units. Again, the fundamentals and the fundamental and derived quantities and units. So, by the way of introduction, what do we mean by the fundamental quantities? Remember, I said physics made simple. Fundamental quantities, these are acceptable standards of measurement. That is, they are the quantities from which other quantities are obtained. Examples: we talk of the length, we talk of mass, we talk of time, we talk of temperature, we talk of current, we talk of magnetic flux, and of course we have luminous intensity. All these, they are the fundamental quantities. On the other hand, derived quantities, as the name implies, derived quantities, that is, we obtain these quantities as a result of bringing together of fundamental quantities, either by multiplication or by division. Examples of these derived quantities: we talk of velocity, we talk of acceleration, we talk of force, we talk of density, we talk of pressure. Why are these quantities called derived quantities? Let's have a look at this. Velocity is what? That is a displacement. Displacement all over time. Displacement over time. You can now see we have brought two fundamental quantities together. What are they? The length, which has to do with the displacement. We talk of the time, you can see. So that is why it is being referred to as derived quantities. Let's go to the second one, which is the acceleration. Acceleration simply means change in velocity with respect to what? Time. So you can now see we are now bringing different quantities together. That is why it is being referred to as derived quantity. What is force? That is a mass times acceleration. Density, mass, all over volume. Why the pressure? The pressure is the force all over the area. Force all over the area. Force all over the area. So now, my listeners, you now see that even mere looking at this, you now see that this is explaining the concept that is derived quantities. Displacement on time, velocity on time, then force, which is acceleration, mass times acceleration. We have the density, mass over volume, the pressure, that is the force on area. Now, having dealt with the quantities, in what are they measured? How do we recognize them? So it means we want to talk of the units. In what are they measured? Now, we also have the fundamental unit and we have the derived unit. Just as we have fundamental quantities and derived quantity, we also have fundamental units and derived units. Now, we take the first one, which is the fundamental units. Fundamental units, these are the basic units through which other units are obtained, just as we define the fundamental quantities. They are the quantities, the standard, the acceptable standard of measurement. They are the quantities through which other quantities are obtained. So also, fundamental units, they are the basic unit through which other units are obtained. For example, we talk of the length. The length, of course, is measured in meters. The length is measured in the what? In meters. The mass, of course, is measured in a kilogram. The time is measured in seconds. While the temperature is measured in Kelvin. The current is measured in ampere. While the magnetic flux is measured in Weber. Luminous intensity is measured in candela. Now, all these, it means wherever you see meters, you know they are talking of distance. Wherever you see the kilogram, they are talking of the mass. Wherever you see second, definitely they are talking of time. Kelvin, which is the temperature. Ampere is the unit of the current. So anywhere you see ampere, it means they are referring to the current. The Weber, the magnetic flux, and of course the candela, which measures the luminous intensity. Now, the other one that we want to have a look at is the derived. We have what? The derived units. My viewers at home, do not forget the word derived. Just as we said, derived quantities. The quantities that are obtained as a result of a combination of two or more fundamental quantities. Now we now go to derived unit. Derived unit, these are the units that are obtained as a result of the combination of one or more what? Quantities. Now we have this, that is, we talk of velocity. Look at velocity. The velocity has meter per second. Mark you, M, as we said, for length. That is our displacement here. Both length and displacement, they are measured in meters. And second, we have time. So it means velocity has to do with displacement as well as the time. Then we talk of the acceleration. We talk of the acceleration. Do not forget our acceleration, we said it as change. Change in what? Velocity of a body. Change the velocity of a body with respect to the time it takes the body to what? To change. So, do not forget, what do we say is the unit of velocity? That is meter per second. And again, all over second. So, this one I give us meter per second, which is also referred to as meter per second squared. Then we go to, that is the force. The force, what do we say is the force? Force is the product of mass. Mass. What is the unit of mass? Kilogram. And we talk of the acceleration. Acceleration. Now we have just found the unit of acceleration. That is times meter per second squared. And this is also referred to as a what? Newton. The unit of force, which is also the unit of the Newton. Then we talk of density. Density, of course, it is a what? Mass of a body all over the volume. What is the unit of mass? That is the kilogram. And of course, our volume, that's a three-dimensional shape. We have a meter for one, area for two, and the third one, which is the volume per meter cube. That is our density. And the last one, which is our pressure. Pressure. Pressure, do not forget, we said pressure is force all over what? Area. What's the unit of force? Now, of course, we have, what do you have? We have kilogram, meter per second squared, all over the area, which is meter squared. So, somebody can say, this one is kilogram, meter per second squared. Then here we have times, you know, if this one goes up, we have meter, this. And this one simply means kg per meter per this. So that is the unit of our pressure. And do not forget that the pressure is what? Is force all over area. So you can now see all these units. How do we get them? We got them as a result of combining one or more quantities. That is, we are combining two or more quantities together to arrive at those units. So those are the aspects we are going to talk on today. If you enjoyed this video, make sure you subscribe to the channel. Thank you.